Okay, let's unpack this. You're tackling topics like differentiation and integration in your studies.
Yeah, and they can feel pretty abstract, can't they?
Totally. All those curves, slopes, areas under curves.
Yeah.
It seems far removed. But what if I told you these exact math tools are like fundamentally linked to something really concrete?
Okay.
Like keeping food safe to eat seriously. We're talking food security here.
Right, and what's fascinating looking at our sources is just how applied these concepts become.
How so?
Well, the sources zero in on differentiation specifically. They show how it's used as a practical tool.
A tool for what?
For analyzing something called decay rates in food.
Decay rates? You mean like how quickly an apple browns or milk goes off?
Exactly that speed of change, that's the decay rate. Differentiation helps measure it.
Okay, so the speed at which food quality or safety declines.
Yeah.
And the sources we're looking at today show how differentiation helps pin down this speed.
Precisely. It's not just about if something will eventually spoil, but, how fast it's changing at any specific moment.
The instantaneous rate of change, that derivative stuff.
You got it. And by understanding that instantaneous rate through differentiation, the sources explain how researchers are aiming to find what they call a suitable formulation.
A suitable formulation. That sounds kind of technical. Is it like a recipe?
Not quite a food recipe, no. It's more like a mathematical model. An equation, or maybe a set of equations.
Okay.
And this model's job is to accurately predict shelf life, but under different conditions. Think temperature changes, humidity, that sort of thing.
Right. Conditions that actually happen.
Exactly.
So for this deep dive then, our mission is basically to pull out these key insights from the sources.
Yeah.
We want to show you how this maybe unexpected connection between your math studies, especially differentiation and measuring rates of change, and food science is just crucial.
Absolutely critical for predicting shelf life.
Which is a huge piece of the whole food security puzzle, isn't it?
Mm-hmm. It really is.
It's super relevant if you're like staring at a derivative problem right now and wondering what it's really for.
Mm-hmm. This is one very real answer.
So where does that leave us? What does this all mean?
Well, we've seen how differentiation, that thing often taught as just finding the slope of a tangent line on some graph.
Yeah.
It translates directly. It measures the actual speed of decay in food.
Okay, so imagine plotting food quality over time on a graph. Differentiation lets you pinpoint how fast it's degrading, like right now, not just the average over a week.
Exactly, at this very second. And if we connect that to the bigger picture, understanding that instantaneous rate of decay is fundamental.
Fundamental how?
The sources show this is the raw data, the information you absolutely need to build that suitable formulation we talked about.
The predictive mathematical model.
Right. Without knowing the rate of change at different points in time under different conditions, you can't accurately model how long the food will stay safe or appealing.
So it's about moving beyond just seeing the overall trend, the curve of decay.
Yes. And understanding the forces, the speed, acting right now to make better predictions about the future.
It really makes you think, doesn't it? That sell-by date on the milk carton or the advice on how long to keep vegetables.
Mm-hmm. So much of that is underpinned by this kind of complex analysis, analyzing decay rates.
Using differentiation. Wow.
And it kind of raises a final question, maybe. Something for you to think about.
Go on.
How many other systems that you interact with every single day, maybe logistics, getting things delivered, or finance, or even public health planning?
Yeah.
How many might also be quietly relying on these very same mathematical tools, differentiation, integration, modeling the stuff you're learning right now?
Uh-huh. It's a good point. It's not just theory in a textbook.
Not at all. It's often the hidden engine, driving practical safety and efficiency all around us. Something to chew on.